Mole fraction we talked about when we were doing gas laws previously in first year chem. Mole fraction is represented by chi, which kind of looks like an X. It does not have units, and you need moles of each substance in the mixture. Mole fraction has to be less than 1 because it's a fraction, but you're going to turn that fraction into a decimal form when you submit your answers. So if we are looking for the mole fraction of gas A, I would put moles of that gas A, or whatever substance it is, over total moles in the mixture. So a mole fraction doesn't have to be gases. We generally use them in the gas law unit, but it can be a mole fraction of any mixture. So moles of whatever substance you're looking for over total moles. Don't multiply by 100 and then just leave it as a decimal. So in this problem, we have 3 gases, and they give you the mass of each. Go ahead and pause the video and find the moles of each of those 3 substances. You should have gotten 1.25 moles of oxygen, 15 grams of neon. Notice oxygen's diatomic, so you should have had a 32 on bottom, while neon is not, so that's why we just used 1 neon. And bromine is 0.150. So the next step is read the question. It says, what is the mole fraction of neon? So I need to put neon's moles on top and the sum of all 3 on bottom. That equals 0.347. If I had found the mole fraction of oxygen, neon, and bromine and added them up, it should give me 1. So the only way to change it is if the problem said what is the mole fraction of oxygen, I would have had 1.25 on top. The denominator would have still been the same. Percent composition is part over whole times 100. So whichever element you're trying to find the percent comp of, it's molar mass from the compound over total mass. So find the molar mass of the entire compound, and then we'll use that formula. So for instance, if we are trying to calculate the percent hydrogen in water, we first write the formula. Then we need to find the molar mass of each of the elements found in water. We have 2 hydrogens, each at 1.008, and 1 oxygen at 16. So if we add these up, that gives me a total molar mass of 18.016. I'm only interested in the percent oxygen, so our percent hydrogen, so hydrogen goes on top, and then we're going to put the total molar mass on bottom. Because it's a percent, we need to multiply by 100. Solving that out, we should get a number less than 100. All your percents have to add up to 100. We get 11.1, which means around 89% of it is oxygen. To find oxygen, I would have just put 16 over 18.016. Go ahead and pause the video and try the next one on your own. So they already gave us the formula. To calculate your molar mass, you should have gotten 17.034. And then 14.01 over 17.034 times 100 should have given you 82.4% nitrogen. Let's try one more. Go ahead and pause the video and try this one on your own. So you should have gotten B, nitrogen dioxide. Molar mass is 46. So you should have had 14 over 46 times 100. One thing that we can use percent comp for is to do a mass-to-mass problem. There's a couple of ways of doing these, but we're going to do it in the least amount of steps, which is starting with the number they give you. So 90 grams of nitric acid. And I'm trying to find out of that 90 grams, how many grams are due to nitrogen itself. So in this problem, my answer has to be less than 90 grams because 100% of the compound is obviously not nitrogen because I have 3 elements. I'm going to set up a dimensional analysis table, and it's just a simple 1-step gram to gram. You always put the total molar mass, because of every 63 grams of nitric acid, so many grams are nitrogen. So I look at the compound, there's only one nitrogen. So 14.01 grams of 63 is due to nitrogen. Multiplying and dividing, I get 20 grams of that 90 was due to the nitrogen. Had I been looking for the grams of oxygen, the only difference is I would have put grams oxygen on top. But I wouldn't have put 16 because I had 3 oxygens. I would need 16 times 3 on top. So go ahead and pause the video and try this last one on your own. Restart when you have an answer. So looking at this problem, you should have started with 155, set up your dimensional analysis. Always put your units in first. That tells me that I need the molar mass of aluminum chloride, which is 133.33. If you put 35.45 on top and left it alone, then that's incorrect because we have 3 chlorines, not 1 chlorine. So 3 chlorines have a mass of 106.355. So multiplying and dividing, we can see that of 155 grams of aluminum chloride, 123.6 grams is due to chlorine.